Good morning students. In this video we are going to study about our third chapter of physics, force and pressure. As we all know that in our day-to-day life there are various situations where we have to apply forces. For example, when we have to open a door, when we have to lift a bucket and many other works where we have to use force by acting in a different way. As we all know that force is an act of push or a pull which changes or tends to change the state of rest or of uniform motion of a body is called force. As we all know that force is nothing than a push or a pull activity which change or tends to change the motion or rest position of a body, then there should be a force is applied. As we all know that when force is applied on a body which is free to move, the body starts moving in a particular direction where the force is applied. That force is called the translatory force. For example, we can see such a car is traveling along a straight road, but there are some other situations are also where the force is not as a translatory motion always. So if we see the other motions, we have to see some examples. If we have applied a force on the handle of a door which is fixed at the hinge, the force turned the door around the hinge. This turning effect of the force about a fixed point of pivot is called the moment of the force or simple movement. If the force has a tendency to turn or rotate a body in a clockwise direction, then the moment of force is called clockwise moment. And if the force has tendency to turn or rotate a body in anti-clockwise direction, the moment of force is called anti-clockwise moment. So there are some factors which affect the moment of force also. What all the factors will be there? Let us see. The moment of force depend upon the magnitude of the force applied and the perpendicular distance from the fixed point to the line of action of the force. This distance is known as moment arm, or mathematically we can say that the moment of the force is always equal to the force applied and the product with moment arm. So as we all know that when the pair of equal and opposite parallel forces acting at two different bodies on a body is known as couple force, and when the turning effect thus produced is known as the moment of couple. So the force and moment arm act as an important part of to produce moment of a force. The unit of force is same as the unit of force is Newton and the distance is meter. So combined unit of moment of force is Newton meter. So there are some applications in which the moment of force is used. Let us see all of them. A hand floor grinder is provided with a handle near its rim to increase the moment arm so that even a small force can applied to produce a large turning effect. As we all know that when with our mathematical formula that moment of force is equals to force into moment arm. As we increase the moment arm, we have to apply a less force to produce a moment of force. Similarly, in a bicycle also, the foot pedal is at a large distance from the axle. To turn the wheel of the bicycle, a small force is applied on the foot of the pedal to the two-thread wheel, which is less than the force applied to the chain to move the bicycle. As we all know, see another example, a long spinner is used to loosen a tight nut. This is because by increasing the length of the spinner. The moment arm get increased and even a small force can produce a large turning effect. So by mathematical formula of moment of force, which is equals to the product of force and moment arm, shows that if we increase the moment arm, we have to apply a less force to produce the moment of force, and if we decrease the moment arm, we have to apply a more force to produce the moment of arm. There are many examples in our daily life where we have to use this calculation in any other ways with all. That's all from today's this video. Thank you.